All right, this is some help for 4.03. 4.03 starts our talk on trigonometric relationships. Now, the good thing is this chart that is up here is on the EOC formula sheet, so you don't have to memorize it, but you do need to understand it. So the sine of any angle is the opposite side over the hypotenuse. It's just a ratio. The cosine of any angle is the adjacent side over the hypotenuse, and the tangent of any angle is the opposite side over the adjacent. So, depending on the angle that we're talking about, the opposite and adjacent side changes. Okay, your hypotenuse never changes. The hypotenuse is always opposite the right angle. So, always opposite the right angle, this longest side is always your hypotenuse. So for angle A though, if we look at angle A and call that theta, if we look opposite angle A, then opposite angle A is going to be side A. Okay, so side A or BC. All right, if we look at the adjacent side for angle A, adjacent side is going to be the side next to it, okay, next to it, but not the hypotenuse. So notice this side is next to it, but that's our hypotenuse, so that can't be the adjacent side. So the adjacent side is going to be side B or AC. Now if we look at angle B, so let's change this up a little bit. If we look at angle B is up here. And so angle B, the opposite side for angle B is going to be, if we look opposite, is going to be B or AC. And the adjacent side for angle B is going to be right here. So it's not the hypotenuse. The next side next to the angle is going to be A or BC. So little a or BC. All right, so that's, I think, the first question they're going to ask you on the quiz is just what's the opposite side of a particular angle. So when you're looking at the opposite, you're going to go the side opposite the angle. The side next to it will be right here. All right, the next one is going to ask you, what is the tangent of a certain angle? So remember, you can use your ratios. So let's take a look. Our tangent, let's make sure we know tangent of angle B. All right, so here's angle B. Here is our tangent ratio. So use the right ratio. So our tangent is equal to, tangent of B is equal to the opposite side over the adjacent side. And so let's take a look. For angle B, what is our opposite side? Our opposite side is going to be AC, and our adjacent side is going to be BC. And so then we can plug in opposite side is 5, our adjacent side is 12. And so depending on how the answers tell you to do it, if it says a fraction, then this is 5 over 12. We can't reduce this fraction, right? Because nothing will go into 5 and 12. So 5/12. Or if they tell you to make it a decimal, you do 5 divided by 12. So that's how to find the tangent. The other two questions are going to ask you how to find the sine and how to find the cosine. Now, the only difference with this one, all right, so let's look at the sine of E. Let's look at angle E right here. Okay, so we're talking about this angle. And we want the sine function. Notice up here is the opposite. So the sine of E is the opposite over the hypotenuse. All right, so our hypotenuse, remember, is always opposite the right angle. So this is our hypotenuse. So we don't have that measure, right? But it's a right angle, or I mean a right triangle. if it's a right triangle, remember we can use Pythagorean theorem, a squared plus b squared is equal to c squared. So we can find the measure. The first thing you want to do is find the measure of the hypotenuse. So we can say 16 squared plus 12 squared is equal to c squared, and that is c squared. That's what we're looking for. So we've got 256 plus 144 is equal to c squared. So 400 is equal to c squared. Take the square root of both sides because we want c is equal to 20. So now we know this side is 20. So now we have all the information. Opposite side c is going to be 12 over our hypotenuse we just found to be 20. And then remember, we can reduce that fraction. 4 will go into 12 3 times. 4 will go into 25 times. So 3/5 is going to be the sine of e. Now it's pretty easy to find the cosine of e. Cosine of e is going to be the adjacent side over the hypotenuse. So same denominator. But this time e, the adjacent side, is right here, right? 16. So 16 over, same denominator, hypotenuse doesn't change, 20. So 16 over 20. And now 4 will go into 16 4 times. 4 will go into 25 times. So our reduced fraction is 4/5. The last question has just a little scenario for you. It talks about a ladder being leaned against a house. So here we have a ladder leaned against the house. The ladder forms a 70-degree angle with the ground. So filled in the picture for you here. This angle measures 70 degrees. And it's on the spot of a house 10 meters high. So this distance here is 10. And they want the length from the house to the ladder. So they're looking for this distance. So now you're going to use your calculator and we're going to set up. Look at what they've given us. They've given us the opposite side, right? This is the opposite side. And this is the adjacent side. So look at which formula uses the opposite and the adjacent sides. So that's going to be our tangent. So we're going to say the tangent of theta, this time our theta is 70 degrees, right? They give us that measure, is equal to the opposite over the adjacent. So the tangent of 70 is equal to, we know the opposite side is 10, we're looking for our x. And so we're going to solve for x. So remember, we can just swap these two places. X is going to equal the 10 divided by the tangent of 70. So now you can simply put this in your calculator. All right, so when you put it in your calculator, you're going to put 10 divided by, and then I would use parentheses, tangent 70, close parentheses, and enter. And then when you do that, you should get, if you round it to the 100th position, or they tell you to round it to the 10th position, you'll get 3.6. Let me know if you have questions. Come to one of my Raise Your Grades.